Welcome to this comprehensive tutorial on real-time data processing with Spark Streaming. I'm your name, and today we will dive deep into one of the most powerful frameworks in big data processing. By the end of this video, you'll be equipped with the knowledge and skills needed to process streaming data in real time using Apache Spark. Before we jump into the coding aspect, let's quickly understand what Spark Streaming is. Apache Spark is a unified analytics engine for big data processing, with built-in modules for streaming, SQL, machine learning, and graph processing. Spark Streaming allows us to process real-time data streams with ease. In our tutorial, we will cover the following topics: setting up our Spark environment, introducing the concepts of D-streams, windowed operations, and finally, laying out an example to process streaming data from a socket source. Let's start by setting up our environment. We'll use Apache Spark with Scala. If you haven't installed Spark yet, you can download it from the official website. Once downloaded, follow the instructions to set it up on your local machine or your preferred development environment. To get started with Spark, we'll be using the Scala programming language. Ensure that you have both Scala and the SBT tool installed on your system for building our project. If you haven't installed them, you can use the commands shown here. Now that we have our environment set up, let's create a new Scala project. Your directory structure should look something like this: a project folder which contains a build.sbt file and a src directory for your source code. In your build.sbt file, we will add the Spark dependencies. This includes Spark Streaming and the core Spark library. Great! Now let's create a Spark Streaming application. In your src directory, create a new Scala file named streamingapp.scala. This will contain our main application logic. Let's dive into the code. We'll start by importing the necessary Spark Streaming libraries and initializing a Spark Streaming context. The context is the entry point for your Spark Streaming application. Next, we will set up a D-stream, which is the core concept in Spark Streaming. A D-stream is a continuous stream of data that can be processed in small batches. For our example, we will read data from a socket source. Now, let's process the data. We'll perform a simple word count operation on the incoming data. We will split the lines into words, map each word to a tuple, and then reduce by key to count the occurrences of each word. To display our results, we'll print them to the console. Spark Streaming provides an easy way to output the results of the transformations we've applied. Finally, we need to start our streaming context and await termination to keep our application running. This is crucial as the application will wait for the incoming stream of data. To run your application, you'll need to start a socket server. You can do that using the nc netcat command. Open a new terminal window and run the following command. Now, let's recap what we've done so far. We set up a Spark Streaming application to read data from a socket, performed some basic transformations, and printed the result to the console, all within a few lines of code. This demonstrates the power and simplicity of Spark Streaming. What if you want to perform windowed operations? This allows you to look at a subset of the incoming stream of data over a given window of time. Let's say you want to count words over the last 5 seconds for every 2 seconds. Here's how you can do that. With this change, you'll be able to see the word counts over the specified windowed intervals. This is particularly useful for processing data streams that require aggregation over time. As you can see, Spark Streaming allows us to perform a wide array of transformations and actions on data streams, making it a powerful tool in real-time data processing. In addition to reading from socket sources, Spark Streaming can integrate with various other sources such as Kafka, Flume, and Kinesis. Now, let's summarize some best practices when working with Spark Streaming. First, ensure to choose appropriate batch intervals based on your data ingestion rate. Second, monitor your application for any bottlenecks. It's a good idea to include checking the Spark UI for understanding the performance of your streaming job. Next, consider the fault tolerance of your application using Spark's checkpointing capabilities, which enables your streaming applications to recover from failures. To implement checkpointing, you can add the following line to your streaming context initialization. In addition, always remember to manage your resources wisely. Depending on the scale of your data, running Spark on a cluster might be necessary to ensure efficient processing. You can leverage cloud services such as AWS, Google Cloud, or Azure for your Spark deployments. Now that you have a good foundation on Spark Streaming, I encourage you to experiment with different streaming sources and transformations. Try connecting Spark with Kafka or consume data from Flume. You can also explore machine learning integration where Spark Streaming can feed data to ML models. Before we wrap up, let me highlight some resources for further learning. The official Apache Spark documentation is an excellent place to deepen your understanding. You can also find various online courses, blogs, and community support to continue your Spark journey. Thank you for joining me in this deep dive into real-time data processing with Spark Streaming. I hope you found this tutorial insightful and that it sparked your interest in big data technologies. If you like this video, please give it a thumbs up and don't forget to subscribe for more programming tutorials.